Okay, so question 3, well this first question again is a recall question. Most tick box questions are recall, that just means you should know them. Now notice here, this question is about magnetism. Which two materials are magnetic? So 2. They will always tell you 2 again, so that means you should be ticking 2 boxes. And in this case, the answers are cobalt and nickel. Okay, now it's worth 2 marks, you get 1 for correct. Each correct answer. If you have marked 3 boxes, you get 0 marks. Okay, don't just get 1, 0. So if you tick more than 2, you get nothing. So make sure you're very clear there. Okay, this next one, it says describe. Now this is quite a good point. That is usually about, a description usually is something like, tell me what you see. Or what you're doing. I don't care about why you're doing it or anything like that, it's just a simple, how do you do it? Tell me how you do it, tell me what you see. So we want the magnetic field of a permanent bar magnet. Now, what I would do on this question, okay, now we've done this. What we did is we had our bar magnet, if you remember, and we drew it like this. We put our north and a south, can't remember which way we did it. We then used a little compass, didn't we? Okay, and wherever that compass pointed north, we did a little dot. And then we kept moving it around. So if I were you, I would kind of doodle to myself down at the bottom. Now we've got to put that into some words here. Okay, so marking points. We used a compass. Okay, or compasses, you could have said, with 1 mark. Okay, and you place that around the magnet. So with another mark. Okay, and then you place a dot where the magnet pointed. There's a few different ways you could explain that third marking point. You've got where the needle pointed or where the needle showed the direction, but that third marking point is all explaining where you'd put your dot. Okay, and there's 3 marks. 3 points there. Okay, so now this next question ends up where you've got to draw a graph. Let's just go through this. So it's really important to read this information, okay? Every single word, every single sentence has been studied for hours and hours and hours. If it's on this paper, you need it to answer the question. So, a student investigated how the number of turns of wire on a solenoid affects the strength of the solenoid. So, again, you've got to know this word. You've got to know about this being this core with the wire around it. Basically, it's like a different word for an electromagnet almost, okay? So I would maybe draw it just, okay, solenoid. There's my iron core, and it looks like a needle, but it is meant to be that kind of big screw that we had, and there's the thing around it. To test the strength, she looks at how many paper clips it could lift. So we've done this, so immediately you should be thinking, oh, good, good. Figure 1 shows how she set it up. So again, let's have a little look at figure 1. So this looks very similar to what we have done. You can see that they haven't used a power pack on their diagram, they just put the current on there, okay? Paper clips, and okay, results. So, number of coils or turns in the wire, and the number of picked up. So immediately, I'm going to look at this table and go, right, does this look right? So we've got 0 and 0, looks okay. 4, 3, right, those numbers will look very similar, so okay. Again, those 3 numbers look good. Those 3, what you're looking for here is you're looking for any results that stand out that might be a bit odd. Now, just on the face of it, I don't think any of them look odd, or the posh word is anomalous, okay? Are any anomalous results? Are there any results that don't fit the pattern? For example, if this one was 2 instead of 8, I'd be like, oh, that's wrong. I shouldn't, that's something wrong, I wouldn't use it. So what they have done is they're asking you to use this data to complete the graph. Okay, now before I even turn the page, just a couple of things that you should know. First of all, the far left column is always the independent variable. And that is always on the bottom of your graph. Okay, left bottom. So the left-hand side of the table is the bottom of your graph. Now we don't do test 1, 2 and 3. We always only plot the mean. Okay, and it is the mean number of paper clips. Okay, this is what we call our dependent variable. So that is always on the right and always on the side of the graph. So left bottom, right side. Okay, when you plot graphs, that's what it should be. So look, it's telling you how you're going to get your marks. We need to plot some points and we need to draw a line of best fit. Now remember, a line doesn't necessarily mean a line. It could mean a curve, particularly in biology. So it could be a line or it could be a curve. Let's just go over and see. So now you're quite lucky here because they have already put the axes on for you. Okay, so we're good there. Now they've done the first two, so we have got to go from 30 to 60. Okay, now you need to plot very accurately. So you will only get the marks here. It's worth 3 marks. You get 2 if you plotted them all correctly, and you get 1 for your line of best fit. Now, you should do this in pencil. I only got a pen to hand, but make sure when you plot graphs you do it in pencil, please. So we want 30 and 12. So before we plot, let's make sure we know what our axes are. So that's 5, 6, 7, 8, 9. Now this is quite a nice scale. They're only going up in ones. So it's quite easy. So what was it again? It was a 12, wasn't it? So 10, 11, 12. Okay, so let's go across. So 10, 11, 12 is on this line here. And where's 30? Oh, it's there. Okay. Let's plot the rest of them. We've got 40 and 15. That one's quite nice as we've got 15 and we've got 40, so we can go straight up across there. 50 and 21. So making this quite easy for us. It's looking like quite a nice line. And 60 and 25. So it is rather nice line. Now again, I'm a bad student because I have not got a ruler. You should all be using a ruler for this. I would get your ruler and I would turn. Now if you have a little look, what you can see is it follows a nearly perfect line, okay? Can you see how that point is just ever so slightly out? So I would get your ruler, okay? Now if it was perfectly straight, we could just draw it perfectly straight. Let's just check that point because it is slightly out. Yeah, we definitely did it correct. Okay. Would always just check if you've got one that looks a bit iffy. Now this is where you go, where do I draw my line? And because all those points are on line and that one isn't, what I would tend to do is just shift your line ever so slightly down, okay? Because you can't really say it's going through that point, and so we'd end up with, whoopsie, that's why you should do it in pencil. Okay, if you made that mistake for real, like I've done in pen, you would lose the mark for your line of best fit. So that is why you do not do it in pen, like I am being a bad example. Okay, it should be a perfectly straight line. It should not have any fairy bits or any extra bits. You should always use pencil. And I've just demonstrated why. So you get 2 points for your plots, if they are correct, and you get 1 for your line. It should be a smooth straight line with no squiggly bits there. So you need a ruler, unlike me. I've just demonstrated why it's very important to use a ruler and a pencil. Now, look, we've got this word again, describe. What does that mean? Tell me what it looks like. So what does that line look like? What is happening? Now, this is saying on the mark scheme that it is directly proportional. However, that point is slightly out. So directly proportional usually means that this is a straight line. So as this number increases, that number increases by the same amount. So say if every time this increases by 10, this is increasing by 1, 2, 3, 4. By 10, 1, 2, 3, 4. 1, 2, 3, 4. Now that is the case. Can you see? Every time that increases by 10, this is increasing by 4. So if you notice your graph where this is always going up in 10, this is always going up in 4s. There's always a difference of 4. If you notice this pattern where this always goes up by the same amount and that always goes up by the same amount, that means it is directly proportional.